Polyatomic ions. What do you guys think of when you think? Do you guys?
Many atoms.
Exactly. Poly means many, and atom means, or atomic means atom. So it's ions made of multiple atoms. So it's made of more than one. And then you have your polyatomic ion sheet that gives you lists of them. So there's a bunch of different ones that we see. So in these, they have a charge at the end. So like, let's look at phosphate, which is PO4 3 minus. For our polyatomic ion, it's telling us we have 1 phosphorus, 4 oxygen, and the whole thing is a -3 charge. So we treat them the exact same way with our naming and figuring out compounds, but instead of putting the charge with like one of the atoms, we just put it with the whole thing. So some of our examples, these are just some examples of polyatomic ions. Nitrate, sulfite, phosphate, hydroxide. You might have heard of hydroxide when we do like acids and bases, which we'll talk more about that when we get to that section. But got more than one atom, and there's a charge associated with the whole thing. So how we use them in our naming is that if there's more than one, we put parentheses to denote that there's more than one of that whole entire polyatomic ion. So this is telling us that we have one barium atom, and we have 2, what is that? What ion is that? Look on your sheet.
2 iodine.
Well, what's the whole ion called? When you look on your periodic, or not your periodic table, your chart. I said the wrong thing. You look on your chart, and you find IO3. IO3 is,
Does that mean there's 2 iodine?
it's iodate. IO3, and what charge is it? IO3, I think it's just minus.
Just minus.
You see it? IO3 minus is iodate.
Wait, why is the minus not in that?
So, because this is telling us that by itself, it has a minus charge. But the reason it bonds is to get rid of that minus and make it neutral. So, barium has two valence electrons. This is telling us this whole thing is a minus, so it needs, or no, I'm sorry, minus, so it has, I'm explaining this in a weird way.
Does it have 3 valence electrons? I mean,
Let's not do the dot structure. We'll do the swap and drop makes more sense with these. I mean, you can draw the whole thing out, it's just more complicated. But barium has a charge, so what charge is barium ion?
+2.
+2. So we still do swap and drop, just now we're swapping this 2 and this 1. So that's why we swap it. But this 2 doesn't just affect the oxygen, it affects the whole thing, so that's why we have to put parentheses to our 2 out here. Does that make sense? So this is saying we have 1 barium and we have 2 iodates. So the name of it, we just say the name of this first one, which is barium. And we say the name of our polyatomic ion, which is, and that's the same.
So, so the I and the O. So is it like?
Yeah, I don't even know.
But I'm trying to put it in like words. So does that mean you're taking a covalent bond first and then making it an ionic one? But like you take that first compound and then add it to it now?
You could say that the I and the O are bonded covalently, and then that whole covalently bonded thing is now ionically bonded to the variant.
What I understand is that there's only one iodine. There's 3 oxygens when iodine needs 1 electron, oxygen needs, well, if you have 3 of them, they need 6.
We'll talk about this more when we get to covalent bonds.
Why
it's like that, because there's some weird rules and stuff.
So I'm just.
But yeah, you're just getting ahead, so it's okay. Yeah, but for what we're doing right now, all you know is when it's in parentheses, it's telling you to look at the whole thing in parentheses, and you look on your polyatomic ion chart and find it, and you just write its name.
Okay. So are the polyatomic ions like having groups of monomers for
Not quite. So it's just instead of having a sodium and a chloride ion that are bonding, we have 2 atoms already bonded, and now they're bonding to another. Yeah. So how many of these do I have?
A lot.
I have a lot. Okay, that's what I thought. So let's do a couple more where we're naming them together before I let you try some, because these are, yeah, that's okay. So this first one, Ga, find Ga on your periodic table,
Gallium.
which is
13.
gallium 13. So its name would be gallium. And then we're going to look on our chart of polyatomic ions for CNO,
It's
which is where?
snow.
Oh, it's CNO. Like if you want to not on your list, that is off.
It's not on the list.
So if you want to not on the list, I'm sorry.
I
I didn't actually double check. I just assumed that it was on.
Yeah, I see CN, but not CNO.
But never mind, forget that one.
Oh.
I'm sorry, because I should have given you that one. I didn't realize that.
Man.
I'm sorry. This one is on the list.
Pretty sure.
Pretty sure. Yes, that one is on the list. Okay, so we'll do this one instead. RB is what? Rubidium.
Hey, that's not in parentheses. What does that mean?
So because it's not in parentheses, we're still looking. This is still a polyatomic ion. We just have one of them instead of 2 or 3. So we're looking for Cl.
Wait,
that's
is
a
the
CL?
number
Is
outside or inside? Wait, is the number outside the parentheses like? Does that mean?
This is telling us how many of this whole thing we have.
Okay, so that's why it's not in parentheses because there's only one.
Right, it would be like the same thing as putting a 1.
Okay.
But we just not do that. We just fixed it.
Yeah, the ones that said the.
Okay, I got you.
This should, I'm pretty sure this should be an L. I should not have this font because you can't tell.
Filigree.
Can you tell the difference between an I and an L in that though? I don't think you can. There, that looks like an L. So it's CLO. So if you look for CLO2, CLO2, did you guys see it? It is chlorite. So it is called rubidium chloride.
And that's what mainly the questions are gonna ask us to do.
Yeah, well then we're just going from the formula to the name right now. Eventually we'll go the backwards way, but not yet, because that one's hard.
So
So we're just doing, this is the easy one. So let's do this one down here. So this is
calcium.
calcium. And then now we're looking for the thing in the parentheses. So we're looking for SO4. We're looking for the fourth, so hydrogen sulfate. H. It's got an A. So you gotta be careful what we're looking for. Sometimes it's one letter difference. Sulfate is different than sulfite. It is different than sulfide. Which will also be different eventually from sulfuric and sulfate. But anyway, we won't get to it. Do you feel kind of okay about these?
Yeah.
Just this part, just going from the formula to the name. Okay.
Yeah.
Try those.
All the rest.
Those three. They're just three. Just three.